All right, you may choose to label this blank periodic table similar to what I colored and scanned into and put it into the drive. You can do that for your notes if you choose. So this blank one could be turned into this one here if you choose, and that's not a bad thing if you want to have it where it's missing all the information inside except for the families and some information about metals and nonmetals and metalloids on there. That's fine. But if you do create this, I do need you to know that you're only going to be able to use this periodic table, in which by just looking at this periodic table you can decipher information about a particular element that I need you to find out some information about, like protons and electrons and some different examples. So the first thing I'm going to cover here is just I'm going to use this periodic table only and try to make sense of knowing the arrangement of the periodic table. First things first, the periodic table is arranged into columns and rows. There's 18 columns, and the columns are vertical on the periodic table, meaning that they go up and down. So if you're looking at the star reference material that I gave you on the first day of class, this is a column that I just highlighted in purple. And so if you look across and count them, there's 18. If you start at hydrogen, column number 1, and move over to helium, column number 18, that's what we call the columns. They're also called groups. So vertical, they're similar in similar in chemical activities, and mainly valence electrons are why they're grouped in the columns. But groups are columns, columns are groups, and then we also can say that they're going to be referred to as the family. So a family is also vertical. So some things that you need to understand. What I'll ask you when I say a group, then that is going to be the vertical column and the number at the top, and then a family is going to be the actual name of that family. And it may be more than just a column, but most of them are going to be one single column on the periodic table. So that's what I'm talking about: group, family, column, up and down, vertical. So the other thing that will be referred to as a row or a period. There's 7 rows on the periodic table, and they are left to right. And so hydrogen and helium are in the first row of the periodic table. And then we move to the second row, which is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So we have 8 elements in the second row. But the periods are rows, and rows refer to energy levels, but they're left and right, and there's only 7 of those. So this would be, when you're talking about a period, a row on the periodic table, that's referencing the number of energy levels that an element has. And if, for example, if you're hydrogen, you're in period number 1, you have 1 energy level. So your Bohr model would have a nucleus with a proton in it with 1 energy level and an electron in it. So we'll get into more details about Bohr models and the periods and the rows, but right now a period is left and right on the periodic table, and it equals the number of energy levels that that element has. All right, so let's talk about the name and list the names of the families of the periodic table. The first one that we'll label is this column right here, and that is called the alkali metals. And I'll try to do my best to write those in conjunction with the column that it's in. So column number 1, group number 1, those are called the alkali metals. All right, so the next column, column number 2, group number 2, this family is called the alkali earths. And they're the alkali earth metals, sometimes is how I will refer to it, or just alkali earth is good. And then we'll drop down to the next column, which is group 3, but the letter changes to a B, so we're in a different place. And this one's more than just one column. It's actually going to be a total of 10 columns, and it's a large portion of the periodic table that we call this family. So the following that are green, all of these elements here in the middle of the periodic table, they're in a family called the transition metals. Because they're more than one column, but they're the ones with the letter B as far as their group number. And their column would be 3B, and it gets a little strange down there at 2B, but it's the middle portion of the periodic table. Just check out the end. It has a B. That column has a letter B. That's a transition metal. When you jump up from the transition metals, this is the 13th column, but I don't like to have the 13 because sometimes it leads to confusions about the valence electrons. But this family here, and it gets a little strange as far as the families. The families aren't necessarily going to be how other videos show it, so it gets a little strange. It's not always cut and dry like the alkali family or the alkali earth family. So what I like to do right now is to identify the metalloids in that family. If you notice on your star reference material, there's a bold line that is underneath in between boron and aluminum, element number 5 and element number 13. So the following elements that I color this peachy orangish color are metalloids. Metalloids will touch that line. They're on either side of the line that divide the left side from the right side. The two elements at the bottom, we really don't get into asking many questions about them as far as what they are. We can just group them in that they are following the trend that if they're on this line, then they are a metalloid. Now there is one exception to the being right next to the line that gets confusing as far as what family is it in, and it's aluminum. Aluminum is not N-O-T, a metalloid. It is a metal, so you do have to be aware of that one. And so aluminum is a metal, and so are the other elements that I did not color green. They're all metals. Okay, they're all metals. They're called other metals. If you just say that they're a metal, that's fine. I understand. They're not a transition metals, so it gets a little dicey sometimes on what the actual name is. But if you just don't call them metalloids. Okay, they're metals. Okay. All right. So if that's clear as mud, the other family. So we have metalloids. Are those peachy colored ones. And the metalloids help us determine as far as is it a metal, non-metal, or metalloid, and then sometimes it's the family that it is in. All right, so now I'm going to skip just because it helps us fill in our non-metals a little bit easier. And so the last two families really don't have numbers or columns that I can just look at and say these are this family, because it's more than just one, and it's either a diagonal line like the metalloids, or it's a huge chunk of the elements in the middle, or they're a small group in between the transition metals and the metalloids. But now I can go to column number 17. This column here, fluorine, chlorine, bromine, and iodine, the one that's in another purple color. That is a family called the halogens. So I'm actually going to put the number 7 in halogens. In the family right to the right of it, the last vertical column on the periodic table, is column 18 or group 8A. And those are the noble gases. Now, I don't like the column number because it conflicts with what I need you to know for the number of valence electrons, but we have one more group, one more family group that is missing, and so if you know that group 17 is the halogen and group 18 is the noble gases, and you know that the diagonal line that is bolded on the star reference materials and every other one, if it's on that line except for aluminum as a metalloid, then anything that is remaining, those elements, we just simply call them nonmetals. So your carbon, nitrogen, oxygen, sulfur, selenium, those that are kind of a pinkish color right there, those are a group called the nonmetals. So those are the families that I would like you to be familiar with. It may be different than what you've done in the past, but that's what we reference here at Grapevine High School. And then the last family, again, those are called nonmetals. Sometimes the family is the state of matter of that material. So we'll get to that here in a little bit. All right, so I think I failed to remember state like what is important about the group number. It tells us the family. We know that those elements are going to behave similarly and have the same number of valence electrons. So I'm going to ask you how many valence electrons does this particular element have, or this family has what number of valence electrons. Now, the valence electrons is true to the vertical column. Even though we have some families that are larger than one column, when we ask you valence electrons, that whole column is and has that number of valence electrons. For example, the very first column, group 1A on the periodic table, they all have one valence electron. So the column that it's in equals the number of valence electrons. Valence electrons are the electrons on the outermost energy level. So if I move to the alkali earth metals in group 2 or column 2A, those all have 2 valence electrons. We skip the transition metals because they can differ in the number of valence electrons and it gets a little dicey, so we don't ask about transition metals and valence electrons, so we skip those. But we can jump over to where we have the metalloids starting with boron, and we know that boron, aluminum, gallium, indium, and thallium, that column there, all of those have 3 valence electrons, and this is where I don't like to use the column of 13, and in order to help me with the valence electrons, I like to use 3A, because that tells me the number of valence electrons is 3. So carbon, all the family, even though we have different family names, we have a metalloid, and these are mixed groups, we have a non-metal carbon, and we have a metalloid silicon, they all have 4 valence electrons, okay? And then the next group, nitrogen, they're all nitrogen, phosphorus, and arsenic, and those are going to have 5 valence electrons. Then the oxygen, non-metals, in that column, they're all going to have 6, and then the halogens all have 7. And then be careful with the noble gases. Most of them have 8 valence electrons, except for helium, which only has 2. So groups equal valence electrons, outermost electrons on the electron, or the atom of that. So that's what I need to hopefully make sense on families and names and what I'll be asking you. Again, you need to be able to use the star reference materials for knowing those family names. All right, so I put in the drive a worksheet that will practice your skills of looking up information about an element. And so I'm going to go to that right now. And this is what you just need to be able to read the periodic table. So this one, I thought I had it. This one right here. Okay, so sometimes I give you the name of it, and then you just find it on the periodic table and start extracting the information about that element on the periodic table. So for the first one, obviously, I give you the full name, so you need to find oxygen on the periodic table. Oxygen's a nonmetal. Nonmetals are going to be located on the right side of the periodic table. The metalloids divide the nonmetals from the metals. Okay, so oxygen is to the right of the metalloids, so it's a nonmetal. and that's actually the family name of it. But anyway, I'm looking at the periodic table. The periodic table will tell me the information that I need to know. So when I find oxygen, I need to know how to answer the following questions. I need to know where there's oxygen. That's a little bit too dark. There we go. There's oxygen. I need to know what the number at the top is. The number at the top is the atomic number. The atomic number tells me the number of protons. It identifies the element. It also, when it's neutral, has the same number of electrons. So right now, if it's a neutral oxygen, we have 8 protons and we have 8 electrons. The next thing below is the chemical symbol. It's the shorthand way of writing the element's name. And then below the symbol, we have a thing called the atomic mass. And we will get into more details about what the atomic mass is actually. But for right now, when I ask for your atomic mass, you copy that number down exactly as it is on and from the periodic table. If I ask you about mass number is going to be slightly different. Okay, I'm asking you a different question, so you should get a different answer. They're both numbers, but they're different informations. And then you have the full element name at the very bottom. All right. So we go to fill in this worksheet out. And practicing, I have the answer choices in there. So I'm going to be doing this without the help of the periodic table as far as on the computer screen. All right, so answering the questions for oxygen. Now, sometimes they're easy, like the first one. I give you the name, you find the symbol, and you say simply an O. I know what the atomic number means. The atomic number means the number of protons, so I have 8. The mass number is the number of protons plus the number of neutrons. It is what is the nuclei of that atom. I know that there are 8 protons in oxygen, so it has to be 8 at least, but it's way more than 8. But to calculate mass number, you take the atomic mass, which is the number on the periodic table for oxygen, it is 15.999. I round that number to a whole number, which is 16. All right, I'm going to subtract the atomic mass rounded. Oh, I don't have to do that for the number of neutrons, sorry. So when I round the atomic mass, it's 16. Okay, 8 of those 16 are protons, so the remaining has to be neutrons. So there's 8 neutrons, well that's wrong, sorry. There's 8 neutrons and there's 8 protons. So here's where we get protons plus neutrons equal the mass number. So how many protons, and that's always dictated by the atomic number, and the difference between the atomic mass rounded and the protons is how many neutrons there are, but adding up the neutrons plus the protons gets you the mass number. Number of valence electrons, you look at the group that it's in. It's in group number 6A. So therefore, it has 6 valence electrons on its outermost shell. When you come into the classroom, the big periodic table I have on the wall that's outlined in wood frame, that's what you're going to use to look at the state of matter. If it has a red chemical symbol like oxygen does, it is a gas. If it has a black chemical symbol, it is a solid. Now I have solid metals and I have solid nonmetals, and you have to know if it's on the left of the dividing line, it would be a solid metal, and if it's to the right, it would be a solid nonmetal. So since oxygen is a gas, I need to determine if it's a metal, nonmetal, or metalloid, and I know this by looking at where it's at. It's on the right side of the metalloids, and so this is a nonmetal, and that's actually the name of the family that it's in. So some of them get a little tricky that you have to fill in, like the example, the one right to the right of it. I don't get the element. I don't get the symbol. I give you the number of protons, and then you need to be able to understand how to find out the rest of the information when I give you different starting points on it. Hopefully that was helpful, and we'll see you next time.